Okay, we are learning the second thing in this class, right? Which is called what? Log function. So first we learn its concepts, right? Then we know the log is what? The inverse of which function? Exponential function. Right? So we have the concept. Then exponential function looks like this. Then inverse log, in general, it looks like that. Right? So we learned the concepts, the basic concepts, and which is inverse of the exponential function. Then after that, we will learn what? The basic skills, which in general would be what? Add, subtract, multiply, and divide, right? That's how we learn things. Then that will be in this section we are going to cover today, which is section 10.4 on your page 38. Then we are going to learn somewhat. Solve it, right? Solve the log equations. First we learn concepts, basic skills, then solve it. Then we learn some apps. That's how we usually do for the things we are learning, right? The basic algebra, okay? So the property, we are going to learn properties, which means what? The basic skills, how to add, subtract, multiply, and divide, something like that for the log, okay? So let's take a look, the review, what do we have? So that would be for log 2, 4. What do you think it is? Which we learned last time, right? For the concept. So log means what? You hook it to the power would be the inside, which is what? 2, right? Then if log 2, 8, what do you think it is? That's 3, right? Because 2 to the third power is 8. How about log 2, 16? That would be 4. Log 2, 32. That would be 2 to the what power would be 32? 5, right? Then log 2, 64. That would be 6 power, right? So that's how we are going to deal with it. Then let's see what kind of properties we are going to talk about. Then how we are going to add, subtract, multiply, divide all those log. Okay, so let's look at your example. Okay, page 38. Let's see some samples. So if I have a log 4 to log 2 of 8, right? So it's like a fractions, 1/2 to 1/3. Then we are going to add together, become what? 1 fraction, right? Instead of 2. So we are going to make many logs to be just 1 log. Then we can solve problems with it, okay? Then next time we are going to learn how to solve it. So let's take a look at the characteristics of it. So what is a log 2 of 4? That would be 2, right? Because 2 to 2 powers. So what is log 2 of 8? That would be 3, right? So if you add them together, what do you think? You should get a 5, right? So do we have same base? we are talking about when we add the same base, okay? Then you have two numbers in there. So what do we have? Okay, I'm just looking the situation. Okay, so we have the same base, so it's log 2. What do you think? If the result is 5, what do you think the inside will be? The inside will be 32, right? Because 2 to the 5th power will be your 32. So when we add the two logs with same base, it ends up this way. But from the original 4 and 8, do you have any idea how can you make a 32? From 4 and 8, right? Then 32 would be what? 4 times 8. Is that right? So, what's the property we are going to talk about? What do you think? That means, okay, the first property is if I have same base, right? I have something inside. One is m, one is n, right? Then I end up with the same base. Then how can I obtain the things inside? From the example you can see 4 times 8, right? So when you add two logs, then you multiply inside, okay? But remember, your log will look like what? That's your exponential, that's your log, right? That's your log base something, then something inside. Then we say base cannot be what? Bigger than, when you use base bigger than 0, base cannot be 1. That's given, right? In the meantime, okay, so the inside will say x. Then what's your domain of x? X has to be greater than 0. So what does domain mean is that what kind of restriction you are using for your x, right? So your x from left to right. So x has to be greater than 0. That means inside the log need to be what? Positive number. Okay? So the restriction will be what? Both of them. M and n has to be bigger than 0, right? Both of them, of course, multiplied together will be bigger than 0. Our base has to be bigger than 0. With base, don't use 1. Is that right? Okay? So, that's the first property. So, when you add the two logs, then to make one log with same base, you multiply inside. All right. So if we look more examples, so if we have this. So look at your right hand side of the paper. We have some examples. So we say, okay, I have log 7 square root 22 minus log 7, same base, right? Ooh, I'm writing the wrong one. So, okay, so you have log 3, 7. We're doing the addition right now. Same base. If we want to write it in one log with base 3, what do we need to do? Inside would be 7 times x, right? Multiply inside. So if we have a log base 6, a to the 5th power, plus log 6, a to the 2nd power, what do you think? would be log 6. What's inside? Inside you multiply them. A fifth times a squared. How many a's we have? That would be A7. Right? So that's your first property when you add. How about subtraction? So I just use base 2. So easy for you to see it. So if I have this one, so what is log 2 of 32? Fifth power. So that's 5. Log 2 of 4 will be what? 2. So I should have what? 5 minus 2 is 3. So if I have log base 2, what's inside? Right? Inside should be 2 to the third power should be 8. Then if we try to get 8 from original two numbers, from 32 and 4, what do you think? How can you get 8? You divide them, right? So this one will be multiplied. When you subtract, you need to divide. So let's look at the second property for subtraction. Okay, log b n minus log b n. So with same base, what do you need to do inside? Difference of log, right? Subtraction, you need to divide the inside, right? All the restrictions are the same. Inside of log needs to be what? Positive number, and your base be used bigger than 0 and not equals to 1, right? So let's see some examples. We have log 7 square root of 22 minus log 7 square root of 2. So what do you think? For one base, we need to divide the inside, right? Then you simplify this. You can put it together. 22 divided by 2 is what? 11. Is that right? Then if we have a log, okay, we need to use this to solve problems later. Okay, so even with x inside, right? Inside has to be positive, bigger than 0. We will keep repeating that, okay? So until you remember it, right? Same base, we write what? Log 4. Inside we can do what? Division, right? Then we need to simplify it. Remember your 152b class? A squared minus b squared. You break down the binomials. You need to use formula, right? The difference of square is what? A plus b, a minus b, right? So this one will be x plus 3, x minus 3. So then you cancel out plus 3. What should you have left? That would be log 4 and x minus 3. So when you simplify, when you subtract the logs and simplify it, you have such answers, right? Okay, so we just add and subtract logs become what? One single log. Another one is like this. Another property. So what is log 2 to the 4 of the 4 would be what? 2, right? Then 3 times 2 is what? You should have 6. So if we have that, then you have base 2. That means if you log multiply something, then we want to write a single log without anything outside, all right? Everything is inside a single log. So we use that to solve problems. So let's see. 2 to the 6th power should be what? 2 to the 6th power, 2 is 64. Okay, so that would be 64 inside. So from the given condition, 1 is 3, 1 is 4, then we take 3 away, move inside, it ends up of 64. How can we make a 64 happen, right? With the 3 and 4 given. That's the purpose. Write a single log, everything is inside. Okay, so it just happen 64 is what? 4 to the 3rd power, 3 times. That means when we translate outside to inside, what do we do? Multiplying. Actually, it ends up as what? The power. Okay, so the 3rd property we have, and we call it power property. Okay, so if you have something times outside of log times the log b to the m, and what should we have? Okay, so when we move n away to inside, it becomes what? The power. We call it power property. This one is called what? Product property. Then this one is called quotient property. This one is called power property. We are going to refer it later. Okay? So inside the log, m has to be bigger than 0, b is bigger than 0, b is not 1. But the outside n, we didn't say it's a positive or negative, because outside you multiply them, you can be positive or you can be negative to multiply things, right? So n can be positive or negative. It doesn't matter, you can just move inside for the power property, right? So let's see some examples for the power property to write a single log. So for this one, let's see. If I have 5 log 11 of m, right? If I write just single log, nothing outside, that would be what you move to inside, it becomes power. Okay, so that's your n is here. Okay, so that would be m to the 5th power. If I have a half log 6 and 7, what should I have? If I move inside, it would be 7 to the half power. You can just leave that way, okay? But sometimes we'll have to solve problems, we'll have to use a number. So you would be, actually is what? Half means what? Top is power, bottom is a root, right? So that's a square root of 7. Then we actually use, calculator to find a number for it. Okay? Then, let's see. Another one is one of the property of log. We call it inverse property. Take a look. We talked about in last section, then we have this. Okay? We say if you have a log, then base b, then b to the n power. It's like you can cancel out this. It's just n. Right? If I have a very complicated situation, and we don't test you this much in this class, okay? This cancel out is just n. And let's see. But for your pre-cal, 103B, you probably will use those. So the reason for this, see, log b to the n power n, right? Because what? If you hook it, right, that means I use a base, n to the n power should be inside bn. Are they the same? They are the same. So if I convert this one back to log, it should look like this. Okay? That means that. So what does that really mean? If we look at the numbers, okay, so how does it look like? So if I have a log, if I have a base, and here, base again, base and base, then I can cancel out. This is 1 power, right? So if you look at this, what do you think the answer is? Actually, it's 1, because a to the 1 power is 8, right? But it's the same thing. You have invisible 1 power. You can just cancel out. It's 1, like this. M is 1 power, right? So it's telling you if I have a 5 squared, what's the answer? 2. Or you can do this way by hooking, right? But this is just a shortcut. So 6 to the 3rd power, it's 3. It's like inverse itself. Okay, so and 10, 4, that would be 4. And next one we are going to use is this one. Actually, on your apps, E, what's the E? It's what? It's a special number. It's what? 2.781 something, right? And if 0.25t, t is your time. If you solve problems, have this equation, you can just simplify this, become what? 0.25t. That's the one we are going to use for your apps. Okay? All right. And that's the inverse property. If a base, you can kind of cancel out. All right. Then for this one, we don't really use much in this class. Okay. So the reason for this one is what? If I have, do I have a log bm equals log bm? Right? They are the same. And if I try to rewrite this, right, using the log, rewrite as the exponential function, I use base, hook, this one should be inside. That's the whole thing, to hook. So that means I have base. If I have a base, that's my log. So it should be what? Inside. That's what it means, right? So it's like you can cancel that. You end up with the n. So we call this one called inverse property. Inverse back to the original. Okay, then let's see some examples on this. So if we have 5 log, for your homework, you might have to practice those, okay? So you can cancel. It's 2. That's what it's saying. So if you have 6 log 6(3), that would be what? 3, right? If we have 10 log 10(4), that would be what? 4. That's what we are talking about. All right. Another property we need to use is this one. You need to use quite a bit. Okay, so it's called base change formula. All right. Let me get a calculator, show you a little bit about it. See if you can see. So can you see the calculator a little bit? So every calculator is a little bit different, okay? But you can see it has what? It has a log here, right? And so you only have a log, you don't have a base. So if you don't have a base, the log means what? Base invisible 10. Okay? So you also have ln. Okay? ln here. So ln means what? Log base e. Okay? That's the symbol. What does it mean? However, if you want to find the log 1010, how do you do log 1010? Right? So you just do log, then you put a 10 in there. What should you have? You should have 1. Right? So log 1010 is 1. But if you want to do log 5, if log 5, you know it's 1, or log 25 is 2. But what happens if log 7? Then you cannot do it. Okay? Then we need to use this base change formula. So what it's saying is when you have a base, it's not 10, it's 8. Then you have something inside like 5 and 7. So what do? So you can use base 10, okay? Put m here, divided by log base a, base 10, we use 10, okay? Then put the a in here, okay? So actually you don't have to use 10, you can use any base. So that's why we say base m, base a, right? Base b. So, or you can use what? Natural log. Natural log is what? Natural log means this one is the base e, okay? So if you base e here, that will be natural log, and that's how you do to find the number, okay? So on your notes, we say we use the base change formula to find the value of log with the base other than 10 and e. If this one other than 10 or e, then we use the base change formula to find the value. All right. So if log, let's just see it first. So log 10, what? What's the answer? 10 to the what power is 1? 0, right? So if we use a base change formula, you will have what? Log 1 divided by log 10, base 10, right? So log 1 is 0, log 10 is what? 1. You get 0. If you use base change formula, you will get the same answer. Okay, So if I have a log 5, 1, that will be what? Actually, it's 0, right? 5 to 0 power. Then, but if we look at this, use base change formula, you will have a log 10, 1 and log 10, 5. Okay, so log 10, 1, you know, is 0. Log 10, 5, it's a log. On your calculator, you just punch in log and 5, then you will get this number somewhere, right? Then you divide, still get a 0. Okay? And if you look at log 2, 8, we should get a what? 3, right? So if we use base change formula, so I should have a log 8 and log 2, right? So you use your calculator, find out what is log 8 is, then divide by log 2, you end up it's 3. You can do that. Okay, we are going to use this base change formula to find a number for the base that is not 10 or E. Okay, so on your next page, take a look. On your page 39, we just rewrite this formula again, right? So we say, okay, if I have a log AX, that would be same thing as log B and A, right? So when we write it this way, or you can use the natural log, means log base E, X and A, okay? When we use this, we know, and inside the log, right, has to be bigger than 0. So A is bigger than 0, B is bigger than 0. Then at the same time, if they are base, they are bigger than 0, they cannot be 1. Those are restrictions, right? When the base A is other than 10 and E, we use the base change formula. So on your exam, if we ask you to find log 6/8, okay? As for your homework, then usually you use all the decimal points, then you just round it at the end. But in the meantime, if we just say doing the practice, we use at least 4 decimals. So you don't have log base 6. So how do we find the answer? So we use what? Log 8 over log 6. Right? Then how do we find the answer? Let's take a look if you can see it. Okay. So can you see it? Oh, okay. If I face the light. So I will have what? Log, right? 8. Okay. Then divide by, right? Log and what? 6. Right? Parentheses. Then I hit enter. What do I have? Can you see it? It's about 1.1606. Okay? And so we say log 6/8 equals 1 about, right? So how do I check if it's right? So if I do the hook, what should I have? I should have 6 to the power of 1.1606. Let's try that. See if you can see. Oh, this is difficult. unless I use the desktop. Okay, I can do what? 6 to the power, right? In 1.1606. I'm just rounding it. Okay, then enter. What do I have? 8.000 something. It's very close to what? 8. If I use more digits, then that would be more close to what we have, right? That's how you check. Okay, so what are we talking about? We are talking about all those properties, okay? Add, subtract, multiply, and inverse, and the base change formula, okay? To make it a single log to do that. Okay, then let's practice some using all those add, subtract, and multiply first, and see how we can make it a single log. All right, so we will use the single log for what? For our equation solving, okay? Then we also follow order of operations always. Okay, so we can make a single log, or we can do this way, or we can do it this way. Okay, expand it to many, many little logs. Okay, in the old days, we need to expand it to many, many little logs and to find the numbers. But now we have calculator, and we only need to combine to solve the problems. Okay, for combining. Okay, we don't do this not much anymore. Okay, we don't break down to little one anymore. But since you can do one way, you should be able to do another way as well. Okay, so it shouldn't be any problems. Okay, let's do the addition and subtraction and multiplication to make a single log. Okay, so if we have this one, 2 log 3x plus log 3x plus 1, same base, right? So we just wanted to write a single log with a base, with something inside, a simple one, just like a simple fraction. Okay, so we don't want a 2 here, so we want to move inside by product property. We will have what? Log 3x to the square, right? Then add this. Then if we do that, when we do the addition, then we multiply inside, that will be what? Log 3x squared times what? X plus 1. You can multiply them out, or you can leave as is. Either way would be fine. Okay? Then let's look at the next one. If I have 1/3 log 5m plus log 5n minus 6 log 5p. Okay? So we want to write the answer just log base 5, then whatever inside, right? That's what we want to do. So we have 1/3 outside. Okay, so we can just do it individually, 1 1/3 outside n plus 1/3 log phi n minus 6 log phi p, right? Then if it's outside, move inside. We need to do the product property, not product property, power property, move as a power. So we will have what? Log phi m to the 1/3 power plus log phi n to the 1/3 power minus log phi p to the 6th power. Right? Then, but we still want to write it this way. So what should we have? Log inside is multiplying. So let me see. And 1/3 and 1/3. Right? Then when you add, you multiply inside. And log, then subtract. Subtract, we are going to divide. So what should we have? Log, oops, where is my base 5? Okay, so I should have, those are multiplying, then dividing the inside. So you can just leave the answer this way. You don't want, we say m is what? M is cube root, right? N is cube root. Then you divide it by P6. Then it's the same thing as this one, log base 5. But computer doesn't like that. For the test, you can write either way, but for the computer, they want you to write it that way. Okay? So let's see. Next one, number 3. So we have 2 log base 2 x plus half log 2 x minus 3 log 2 z, right? So we want to write the answer just with log base 2 with something inside like that. So we move inside, outside, move inside, use power property. So we should have log 2x to the square, right? Plus log 2x to the half minus log 2z to the cube, right? Move inside, becomes power. Then when we add, you multiply inside, so that will be 2x squared times x half, right? Then minus means what? Divide. So you divide the z cube, okay? But for the power, you don't do this way, right? You don't leave that way. So what do? You do same base, you need to write a simple, just one base, one power. So 2.5, right? Added together is 2.5. 2.5. But you don't write it in a mixed number. 2.5 like multiplication. We don't do that anymore because for the power 2 and 2.5 doesn't mean anything. You need to change it to what? Improper fraction. 2.5 means what? 5 halves. Because top is what? The power, bottom is the root. So it's z cubed. You need to write the answer that way. Okay? And for this one, x to the 5 half for this one, right? X to the 5 halves, then you don't want to write the 5th power, take a square root, and over z cubed log base 2. You don't do that because computer doesn't like it, but for the test, it's fine because we know the meaning. But for computer to scan over, to check your syntax, they wanted you to do this way. Okay? So what we did was you write a single log, okay, to combine it. All right. Now, since we are doing that, we are going to do the backwards. Okay, we are going to do backwards. So writing the backwards, you might get confused somehow for some of you. Okay, you can always check by combining back. And so, but we don't really use to solve our problem anymore, but we just need to practice the concepts. You know, once you can put it together, you can break down as well. Okay, that's the thinking process we are doing. So for the base, we want to write what? So to break down means what? We want to write log 8, then plus or minus something, and the inside is as simple as possible, a simple thing. So to break down means what? Inside, you just want to have a little tiny thing inside, as little as possible, okay? So for this one, since they are multiplying two variables, so when they are multiplying inside, you break down by adding, okay? Log 8 become x, right? Plus log 8 and y squared, because they are multiplying, right? Break down to add them. But for this one, and inside it's not as simple as possible, just x or y, right? Then you have square. Square, then you have to what? Move away. Then by moving away, it means what? Power you move away, you can multiply them to outside, so you will write what? Log 8x. This one move outside to log 8 and y. So that will be the expected result. That means inside just simple x, simple y, or a simple number. Okay? We don't really use this anymore. So I'm not sure I have this on the test for you to practice or not. Okay? But you need to have a right concepts for your pre-cal and cal. So we should be able to go forward, go backwards. Okay? So this one is a divide. So for division, when we separate the top and bottom, it's by what? Subtracting. Okay? So you will have log 5 mq n minus log 5 and square root of v. Okay? Then to break down means inside just a simple variable or a simple number, right? Then there are many variables with power. They are with the radicals, right? We just want to have v inside. So what do we do? So this one multiplying, then you break down by adding mq plus log 5 and n, right? Minus what? Log 5, v, you change it to power half, right? So you have a single v. Then this one, you want to have a single m inside. So you move 3. For the power, you move to outside, will be 3 log 5m plus log. This is the simplest one for this one. This one you move outside, become half log 5v, right? So that would be the answer expected from you. Then the answer will have what? The inside the log will be as simple as possible. Single variable. Okay? So let's look one more. Base 4, square root 16x cubed and y. Right? It means what? the inside will just have single number or single x, single y. Okay, you don't want to have square root, division, multiplication. So first, what do? We change the square root becomes what? Y 6x third to the what? Half power, right? Then what do? Half power, if a power you move outside, you multiply. So you move half outside by multiplying log 16x cubed and y, right? But inside, too many variables, too many powers. We want to make single variable. So what do? Okay, those are multiplying. You break down will be what? Adding 16 and add log 4x cubed. And dividing will be what? Subtraction. Log 4y. Right? This is already single variable inside. This one you have 3. You need to what? Move outside, right? So half. But for number, you want to make it as simple as possible as well. So log 416 will be what? Actually, it's 2. If you don't simplify this, you get a deduction, right? Because that's not a simplest form. And this one will be what? 3 log 4x. Make the inside the simplest. Just x or y. This one is fine. Then how do you write the answer? You have half, you have to distribute, right? Half times 2, 1 minus half times this, 3 halves of log 4x minus what? Half times half log 4y. Okay, so that would be the answer we expected you to do. If you are still not sure, what do? You combine back. See, you can get this one. Become a single log with a bunch of things inside. Is that right? So we just covered your section 10.4, the properties of log, right? So add, subtract, multiply type of things for the operations. All right, are we good? You should be fine. All right, so you need to overcome the, first difficulty for this class is your log. And next time we will see some apps. Okay? And oh yes, we need to solve equations first. Then we see some apps. Right? So that will be our section 10.4.